Apart from a line of pitch classes, inversion can also be applied to a set of pitch classes. Schoenberg's piano piece Opus 11 No. 1, measure 1 to 5 will serve as an example for our discussion. 3 pitch class sets are identified in the right-hand part of the excerpt and are highlighted in red, yellow, and green respectively in Figure 8. Their respective normal forms are shown in Figure 9. In order to make it easier to understand, the following discussion will refer to mainly the normal form of the sets. A close examination of the pitch classes in set 1 and set 2 reveals that they are related by inversion. The pitch class G in set 1 can be mapped onto the pitch class F in set 2 through the operation of T0I, while the pitch class G sharp can be mapped onto the pitch class E, and the pitch class B can be mapped onto the pitch class D flat through the same operation. In short, set 1 and set 2 are related by T0I. A comparison of set 1 and set 3 will reveal another inversional relationship. The pitch classes G, G sharp, and B in set 1 can be mapped onto the pitch classes B, B flat, and G respectively through the operation of T6I. In short, set 1 and set 3 are related by T6I. Inversionally related sets are considered as equivalent in set theory. 2 pairs of chords commonly used in tonal music exemplify this. The first pair is the major and minor triads. In Figure 11, 3 pitch classes D, F sharp, and A in the first upper part constitute a major triads. There are 2 semitones, 6 semitones, and 9 semitones above 0 respectively. Inverting each of them around 0 will give the pitch classes of B flat, which is 2 semitones below 0, G flat, which is 6 semitones below 0, and E flat, which is 9 semitones below 0, resulting in an E flat minor triads. Both of them belong to the set class 0, 3, 7. Another example concerns the dominant 7th chord and half diminished 7th chord. This is illustrated in Figure 12. The 4 pitch classes D, F sharp, A, and C in the upper part make up a dominant 7th chord with 2, 6, 9, and 12 semitones above 0 respectively. Inverting them around 0 will result in the pitch classes of B flat, G flat, E flat, and C correspondingly. These 4 pitch classes make up a half-diminished 7th chord. Both the dominant 7th chord and the half-diminished chord belongs to the set class 0, 3, 6T. Inversion can also be designated as IXY. This is formulated by David Lewin in his monograph Generalized Musical Intervals and Transformations. The letter I on the left-hand side denotes mirror inversion. The X and Y on the right-hand side denote the pitch classes that invert onto each other. Let's refer to Schoenberg's piano piece again for further explanation. So far, I have discussed only the normal forms of the 3 pitch class sets for the sake of clarity. As mentioned, set 1 and set 3 are related by T6I, which means that the pitch classes in set 1 can be mapped onto the pitch classes in set 3 through the operation of T6I and vice versa. As shown by the red box on the screen, the inversion maps the pitch class G onto the pitch class B, the pitch class G sharp onto the pitch class B flat, and the pitch class B onto the pitch class G respectively. Therefore, the inversion T6I can also be denoted as IBG and IB flat G sharp. If we arrange all the 12 pitch classes in a clock phase as shown in Figure 14, the inversion IB flat G sharp and IBG can be indicated by the red lines that connect the pitch classes. Figure 14 also shows that the same inversional relationship maps C to F sharp, C sharp to F, D onto E, and A and D sharp onto themselves. Therefore, the inversion I B flat G sharp and I B G can also be denoted by I C F sharp, I C sharp F, I D E, I A A, and I D sharp D sharp. Note that all the 7 labels here are equally correct, but it is preferable to use those with pitch classes related to the musical context. Let us also examine the inversional relationship between set 1 and set 2 in Schoenberg's piano piece. We have proved that set 1 and set 2 are related by T0I, which means that the pitch classes in set 1 can be mapped onto the pitch classes in set 2 through the operation of T0I and vice versa. The red box indicates that such inversion maps the pitch class G onto the pitch class F, the pitch class G sharp onto the pitch class E, and the pitch class B onto the pitch class D flat respectively. Therefore, the inversion T0I can also be denoted as IGF, IG sharp E, and IB D flat. The red lines in figure 15 specify these 3 denotations. According to figure 15, the same inversion can also be denoted as IA D sharp, IB flat D, IC C, and IF sharp F sharp. Therefore, the inversion described here can also be referred to as IA D sharp, IB flat D, IC C, and IF sharp F sharp.